Or not, I guess.
Nice.
For our video project, we're going to make a Gauss gun, otherwise known as a magnetic linear accelerator. For this, we need a ruler, steel balls, magnets, tape, and scissors.
This Gauss gun is going to deal with magnetism and conservation of momentum.
This is what our Gauss gun looks like after it's been built. As you see, we have taped down our magnets, we have our steel balls connected. For our magnets, we have them at least 2 inches apart, and then we have 4 steel balls connected to each magnet. Alright, so you're probably wondering how a Gauss gun works. And to be honest, it's pretty interesting. So if you look right here, we have our ball. We're going to put our ball inside our magnetic field. Since it's in the magnetic field, the magnet's going to pull on it. And as it pulls on it, the ball is going to accelerate. Since it's accelerating, it's going to hit the magnet and it's going to transfer the energy that it has towards the magnet. Thus, the ball does work on the magnet.
The magnet now has an energy, and it has a mass and velocity, so it has a momentum. The momentum from the magnet is transferred into the next steel ball in front of it, and from that steel ball into the one in front of it, and so on. This creates a chain reaction until the last steel ball. Nothing is in front of the last steel ball, and it has a weak magnetic force because it's farther away from the magnet, so it launches off with the same velocity of the first ball.
So now you're probably wondering what the velocity is of the ball after it's launched from the Gauss gun. To do this, we'll set this up as a projectile problem. We will use the motion equations to figure this out. Alright, to start this experiment, we're going to have to measure the distance in the y, which is the height of the table. And that is about 31 inches. Also, we're going to have to measure the distance the ball travels in the x, which we'll do once we launch the Gauss gun. This distance to travel is about 17 inches. At the end of this experiment, we'll change the inches into centimeters or meters.
We measured that the height of the table was 0.79 meters. Acceleration in the y is the acceleration due to gravity, so it's 9.8 meters per second squared. The time is what we're solving for. The initial velocity in the y is 0 meters per second because it's shot horizontally off the table, and the final velocity is what we don't care about. We use the motion equation y minus y naught equals v naught t plus 1/2 at squared to solve for t equals 0.4 seconds. We then use that in the x direction, which we found our x minus x naught to be 0.43 meters. Acceleration in the x is 0 meters per second squared. We just found the time. We're going to solve for the velocity. We use the motion equation x minus x naught equals v naught t and solve to find that v naught equals 1.075 meters per second.